G'day everyone and welcome back to the channel. I'm making this video mainly, honestly, as a response video to probably my favourite, most long-term since I started the channel and favourite commenter, Tech. You pointed out a lot of very good points and there was a lot of stuff that I didn't really cover too well in the video, so and the other thing I didn't want to do was give links to this or give a definite wattage figure on it or anything until I'd actually done a bit further testing, because last thing I want is someone to go and order the thing and burn their house down, you know. So anyway, first things first, I want to address the whole 220 volt oversaturation thing. So with a transformer that's actually wound so that it's already running fairly saturated, or a transformer that's actually wound for 220 volts and again runs a little bit saturated, yeah, just a few extra volts puts it, you know, quite heavy into saturation, and that's quite true. But I've also, and like, let me just give an example of this, like my soldering iron station. You see that transformer on the back of it? That's bucking. It's got a 220 volt transformer in it. When I bought this thing, it was that hot, you couldn't put your hand there with it in standby. Now you can't feel anything. Yeah, it makes that much of a difference. And yet, other transformers I have found, such as this, I have found advertised as 220, run them at 240, and they don't even get warm. So there's definitely a few things going on. The resistance of the winding, i.e. how long the primary winding is and how thick it is. Probably the type of lamination winding thing that's used, the core quality of it. You know, if it's actually a 220 volt winding or a 240 volt winding, and the voltage tolerance for it, you know, because it can always be a few turns closer to a 240 volt winding or a few turns closer to a 230 volt winding. They might be running the core more saturated or less saturated. So what I'm trying to get at is some of them, 240 volts on a 220 volt transformer, you'll burn your house down in half an hour. Others won't at all. So I just wanted to point that out, because Tech is more than 100% correct that you know, running an actual 220 volt transformer on 240 will cause it to overheat. In most cases, yep, that's 100% true. This happens to be one of those ones where that doesn't happen. I'd left this running for like half an hour with no load, and it was like barely above, it felt like touching another person basically. Not cold, but not even warm, you know. Like room temperature, not even the warmth of a body, I'd say, you know. Interesting. So anyway, what I thought I'd do in this video, but here's the interesting thing, it definitely is a 220 volt winding, because it's supposed to be 40 volt outputs, and as you guys know, I got, what was it, 45, 47, 46, I can't remember. So it's definitely a 220 volt winding, but like I said, it must run really undersaturated, and you know, now it's only a little bit more saturated, not enough to cause any problems. But like I said, with some other transformers, that is not the case. That extra couple, 20, 30 volts, whatever it is, depending on your grid voltage, will literally make the thing cook and melt, start a fire if there's no thermal fuse in it. Anyway, now that that's out of the way, because I just have to be thorough and explain things like that. I'd hate for someone to burn their house down because I failed to explain something properly. You know, point I'm getting at is I want you guys to use this trick to your advantage, but at the same time, you have to pay attention to the temperature of the transformer basically, because you can't do this with all transformers. Alright, with that disclaimer out of the way, what I'm going to do, I think first things first, I'll just get all these wires so that they're just out of the way. I'm going to just solder the primary in series with a meter that we can actually accurately look at the current draw with. I mean, like, not a clamp meter, like an actual shunt that's in series with it. And we'll look at the no load current on it, running 220 volt transformer at 240. Then what I'm going to do is I'm going to set it back up with the rectifier and the capacitor, which incidentally, I ended up doing testing on this. It's still got an ESR of 0.01 of an ohm and a capacitance of 9,988 microfarads. So, got lucky there. Anyway, I'm going to hook all this back up. But what I'm going to do is I'm going to measure the current on the AC side, the current on the DC side. Just wanted to have a quick look and see what my clamp meter is doing, because I can't even remember how I measured the current last time, or if I even did measure it at all. I don't think I did. You know what? I probably won't bother measuring it in too many places, because I'm not going to be using the clamp meter this time. I'm going to, like I said, put it in series with a meter so that we get an accurate reading. But I'm going to set this back up, do a no load measurement of the current on the primary, load it at 4 and 8 ohms on the secondary, measure the current on the primary with it loaded, and again document what it does temperature wise, unloaded, loaded at 4 ohms, loaded at 8 ohms, might do 6 ohms as well. I want to make sure I document everything really well this time. I might even, like let it run for half an hour, unload it, and get the thermo probe out and take temperatures and everything. I'll make this video as informative as I can, and then I'll put the link for where I got this from down below. So with that being all said, I'm going to get this all set up now. Alright, so I've got no load on the secondaries, and I've got the multimeter very precariously rigged up and balanced there. I'm going to apply power, and we're going to see what the AC current draw is no load. Well, I now have to look into my clamp meter, because last time I checked my clamp meter, it was registering like 4 to 6 milliamps. That's taking 50 milliamps, and my clamp meter didn't say that. That's a bit of a problem. I'm going to have to look into that. Yeah, another video. I have so much work to catch up on here. I'll tell you what, the next few days I've got to get this amplifier finished, because I've still got a power supply to finish, a curve tracer to finish. Oh my god, all sorts of different videos to do. Teaser, and yes, they are germaniums. Anyway, teaser, there's two. Yeah, no, I've got a lot of stuff in the works. Alright, I'm going to unplug that. 47 milliamps once it's running. Alright, let's do some maths on that. Alright, I haven't done the maths yet. Sorry, let me just log into my computer so I can get my volts, amps, watts thing calculator up. I'll tell you what the quiescent dissipation is on that. It was advertised, I think it said 2.3 watts, but like I said, that was for 220. Now, before I do that, let me just explain. I'll do the maths first. Sorry, I've just been setting everything up. I'm getting ahead of myself here. I'm actually getting really confused now, because according to my computer, that's 11.28 watts. I don't understand. I had this thing running. I'm going to have to put a thermo probe on it. I had this thing running, and it felt like I said, touching another human. I would imagine 11.28 watts would heat up something that size a lot more. Might have to leave it running for a bit longer. Maybe I didn't leave it running long enough. Anyway, let's go over the test setup. So the 34401A is looking at volts off the capacitor. I've got the 35 amp rectifier on a heatsink coming off of the center tap on one end of the main winding. I've got the Fluke 115 in AC amps mode in series with my load, which is just here. And I just realized I've got a whole lab of equipment. Why the hell am I using that bloody crap meter over there when I've got all these other meters? So I grabbed the good Hioki AC clamp meter. We'll use that. So that should solve all the problems. Sometimes I just don't think. I tell you, when you get so much equipment, you start forgetting what you've got. It's funny. And then, like, that's what just happened to me. I looked at this and I was like, what on earth am I doing using the other crap? Anyway. So, at the moment, I've got it hooked up for a 4 ohm load. What I've done is I've put, these are 4 ohm resistors. I've got 2 in series, and the 2 banks in parallel. So all 4 are dissipating the power. I don't need them. All that. But anyway, that's how I did it. So that's like that. Oops, one of the wires I taped up is not taped up. That's not good. Should have done a better job. I won't lie, I am rushing this because, I mean, it's only a quick test. It's not like I'm trying to neatly solder everything and... let me just go get the tape, sorry. Okay, that wire is insulated. Alright, so I'm going to turn it on. I'll just light this screen up for you guys. That makes it a bit easier. Going to apply power. We've already got the load hooked up, so let's see how many amps that is. Oh, I'm on AC. Jesus. Okay, no wonder it was getting hot. I was trying to draw way too much current out of it in my last video. So that's good news, because based on my last video, I was starting to think this was maybe not even, you know, it was supposed to be 900 watts continuous, 1800 watts peak. It's not that. I was thinking maybe, you know, 5 to 750 VA, and then starting to think closer to 5, 6, but now maybe it might redeem itself a bit. So let me just reconfigure the load. I know what I'm going to do. I'm just going to set this up for 6 ohms. Alright, reconfigured for 6 ohms now. Okay, that's still 8 amps. The voltage is a lot closer to where I want it. That's good. That's still going to be too much current, I would assume. I'm just going to kill that for a minute and do some math. Alright, that's about 385 watts. Bearing in mind that's off of 1/2 of the winding, obviously an amplifier switching between the two, so one of these transformers is supposed to be going into a 500 watt amp, so if I'm getting 2 times 384 out of it, that's good. Let's see what it does temperature wise. I just want to feel how hot the secondary, how quick the secondary gets hot, because I know loading at 11 amps it really got way too hot, but I'll see how this goes. Can't feel anything yet, so I'll just pause the video for a bit and I'll come back. Alright, this transformer's starting to surprise me. It's only been 1 minute. Obviously the core can't warm up, but the winding certainly can, and I can't feel it. I mean, I can just feel it, but it's not even hot at all, warm even. Let's have a look at AC amperage. 1.95 amps. Sorry, I just realised you guys can't see. 1.92 amps. Do some quick math again. 1.92 amps at 240 volts. That's drawing 460 watts to put out 385. Okay, I can feel literally just warm. Wow, I'm really impressed. I'll tell you what, you guys are going to be getting a link now. I didn't realize in that last video that I was pulling 11 amps out of it. Don't forget, my amplifier is going to be fused for, you know, each rail is supposed to have a limit of about 7-8 amps for the amp that I'm building. So this transformer needs to be able to provide about that. Not all the time, but at least for a while, and it's already done it for minutes. I mean, I don't know any song that produces, say, a continuous square wave at some low frequency for, you know, 3 minutes or whatever. This is already past that by minutes, so it's definitely fine for amplifier use, I can tell you that. I'm actually really impressed with what's going on here. How's my rectifier? Yeah, that's fine. Alright, well, I'm going to leave this running for a little while now, and then I'll come back and we'll take a look and see what's happening. It's really hard to get everything on the camera. Sorry about this, guys. My apologies. As you can see, in the last video when I loaded at 11 amps, the voltage was slowly dropping. I know I didn't mention it, but I did notice it. This is staying stable, so it's not heating up too quick like it was when I loaded it at 11 amps. Alright, it's finally starting to come up to temperature. I'm going to give this another 5-10 minutes and I'll see what I think about it, but I can tell you now, I'm quite happy. I actually didn't expect it to be this good based on my first video. Alright, it's been running for about 15 minutes now. Obviously, at this power and temperature, it's long enough for it to get up to full temperature. And look, it's hot. It's not warm. It is hot. But when I say hot, I don't mean like 60 degrees or anything alarming. It's hot. But I could hold this all day. It's not that hot. It's not a fire hazard. I mean, I've certainly come across transformers that run cooler, but again, considering it's got a 220 volt winding, it's supposed to have 40 volt outputs, and I'm getting like whatever 45, 47 out of it. And on the DC side at 48 volts loaded at 8 amps, continuous, bearing in mind like Tanmera, like you pointed out, Tanmera Tech in an amplifier, and as I was alluding to in the first video, it's not going to be continuous draw on it. So with this thing running as it is, I'm happy with it, and that's continuous 8 amps. This is wonderful. This is perfect, absolutely perfect for the amplifier. Only thing I need to do now, well, let's do some quick maths. 385 watts, it does feel a little bit hot. I would, like to see it a little bit cooler than that. Look, I'm going to say 325 each winding, maybe even 350, but let's say 325 to stay on the safe side. So I'm going to say it's a 650 VA transformer. That's what I think it is. That's my opinion. The thing I need to do now is take the load off, which I have now done, and I'll turn the transformer off too, because I'll let it cool down for a little bit, not completely, but just so it's not hot. Then what I'm going to do is I'm going to power it back up, but with no load, and I'm just going to let it run for, say, 40 minutes, some sort of decent length of time, and then I'll measure what the temperature is of the core with my thermo probe, and I'll let you guys know. that'll give you an idea of how much hotter it's going to be, say, on a summer day when it's inside an enclosure. Just for those of you that might end up buying one. But I can tell you now, in the first video, I don't know how to explain this. You'll probably know what I'm trying to say. In the first video I did on this, I was trying to be optimistic, but I really was sort of losing faith the further I got into it. Now that I've set up all my measuring stuff properly and realized what I was pulling through it, I'm actually really, really happy. So, yeah, it looks like this is going to turn out quite well. Like I said, certainly for an amplifier, go ahead and buy it. Well, as long as it passes the next test and doesn't run too hot with the 220 volt winding at 240, I would say definitely use it for an amplifier. Maybe not for power supplies and things that you're going to take continuous current unless you derate it a bit, you know, say 300 volts for each half of the winding. Make it say 600 VA or 500 VA. Then yeah, you could use it continuously all day at that rating. But it's certainly good enough to build a 500 watt 2-channel amplifier with. I can tell you that as long as it passes the next test, I guarantee you it's bang on for that. And the wonderful thing about that is the thing only costs $48 plus shipping, and the shipping is what costs the most, not the transformer. So it's actually quite a good deal. All right, I'm going to wait a little bit, like I said, let this cool down, come back, power it up, wait again, and we'll see what the quiescent, if you want to call it, temperature is. Alright, so I've just got the transformer hooked up now. Excuse me. Just unplugged the charger out of the phone. Yes, the cap and rectifier is still on it, but that's not exactly drawing much. So now I'm just going to wait for a while, at least 45 minutes, see where the temperature of that goes. Something else I wanted to point out, however, that I forgot just before. I'm not sure if I've got this right or not, but I'm pretty sure if you run a transformer with no load, slightly more on the saturated side, when you draw a load from it, it actually runs cooler than what it does unloaded. I could be wrong, and we might end up testing that in this video. Basically, if this ends up running, you know, a little bit too hot unloaded, I'll put a small load on it. I'll start something small like 50 milliamps and move it up, and we'll see what happens to the temperature of the transformer, and I'll document that too. Guys, one more thing. I just did the math. 385 watts times 2 for the 2 half windings is 770 watts. Obviously, the transformer is going to run hotter because of the 2 windings creating temperature on the one mass, but it's still not going to be as hot as you'd think, like double as hot, because it's not like the winding temperature is going up, there's just more of it at the same temperature. I don't know if that makes sense or not. So yeah, but still something to bear in mind that I am only loading half of the winding, so only, you know, it can probably cool off a lot easier because there's a little bit less mass that's actually actively heating and transferring heat into the rest of the mass that's there and the air around it, if that makes sense. I could have that wrong, but it's certainly something to bear in mind. Like I said, I'll happily put the links for this, but I just wanted to make everything nice and clear so no one risks burning down their home, and everyone, you know, double checks everything and tests their load and temperatures first before, you know, putting the lid on the box and chucking it in the corner and turning on 24/7 and walking away to come back to a burnt down house situation. So this is the other transformer. That one's still over there. But I've got some really interesting information about this one. This one arrived with a nick cutting into 3 of the windings. I took a photo and showed the seller. Didn't have to go through AliExpress, just showed the seller. They shipped me another one for free. So I've now got 3 of these. I'll do a video repairing this. Probably what I'm going to do is just pull some of this plastic back. I might a little bit of a sleeve, like fiberglass sleeve, under and around, like in a U shape. Sorry, in a U shape behind each one of those windings with the slit in it. And then I'll take off all the enamel over the winding and then lay a piece of copper wire over it and flow a bead of solder down it to make it a thicker, stronger piece. And they'll all be insulated because they'll have that U. I'll do something like that, or I might even cut that winding out and just rewind 3 loops. That's still going to be 2 connections. I don't know, we'll see, but either way, it's only a little nick and it's right on the outside, so it's going to be really easy to fix this. It's actually kind of good that they sent this to me because I've actually got 3 for the price of 2, if you think about it. I mean, I can repair that really neat and keep the winding really tight. It's not going to affect the performance at all, so I've literally got 3 for the price of 2 when the other one arrives. But there'll be a video coming on this soon. I've also got the other case. I haven't put it together yet, but the other case for the other half of the 2 amplifiers I'm building has arrived. So good things to come. Alright, so I've left this thing running, and interestingly enough, I unplugged it initially for like 5 minutes to let it cool off, plugged it back in, and it was still warm, and it's actually gotten cooler plugged in. It's literally, I'd say body temperature. Literally body temperature. Like, I'm not even going to bother putting a thermometer on it. I would have if it was like 40 or 45 or something to see what it is, but it's literally like holding hands with someone. It's fine. So I can guarantee you it's fine on 240. I'm still interested to see if it gets hotter or colder with a small load on it. So I've hooked the load bank up, and I'm just going to put, say, you know what, I'll put 100 milliamps on it. Yeah, you know what, I'll put 50. Because it is, I'm on the wrong channel. It is at 62 volts unloaded. I will put 50 milliamps. And I'll turn that on. It's 3.46 watts. And I'll come back again in about 20 minutes and I'll see what this has done, if it's gone up or down, and I'll probably end the video there. I think we've gathered enough data now to reliably say what this can be used for, what it can't be used for. We can say it's good on 240, great for a 500 watt, 250 watt channel amp. No lower than 4 ohms on the output though, I can tell you that. And yeah, I'd say it's probably about maybe 750 VA. I'm still having a hard time making a call on that. Like I said, I've had transformers that run cooler at full power, but that still was doing 385 watts on half a rail. You know what? I think I'm going to do one more test just to make this fully complete for you guys. I'll leave this for 20 minutes, say, with the extra 50 milliamp load on it. And then I'm going to come back and I'm going to hook this back up, but I'm going to hook the other winding up with a second capacitor center tapped, and we'll load both halves of it and see how hot it gets then. I just don't feel comfortable giving a link and saying this Chinese transformer is fine on 240 at this power without verifying everything properly first. Alright, great news. I know you probably can't see on the screen, but I end up bumping this up to 100 milliamps, and I'm still not even sure if this is even any warmer, or that I can detect anyway. So I can tell you now, this thing's fine running on 240 volts, where some 220 volt transformers would literally just catch fire with no load. this is perfectly fine. So what I'm going to do now is probably what I should have done in the first place. I'm going to set this up center tapped, so basically each end of the AC winding will go to the two AC terminals of the rectifier. Positive and negative outputs will go to the positive and negative of two caps. The other two terminals will be connected together going back to the 0 volt rail. And then what I'll do, sorry, I should have moved this down a little bit. And then what I'll do is I'll load both the outputs. It's a good thing I built that 2000 watt load bank. It's really coming in handy. Obviously, I'm only going to be able to do 4 or 8 ohm loads because I'm going to run out of resistor options. But, I mean, I still think it's worth doing the test. If you think about it, if I load both sides at 8 ohms and leave it running for, say, half an hour, I think we can assume that if it was, doing roughly 6 ohms, which is roughly, if you take the losses of speakers with the impedance rise, the cabling, the losses of the transistors, the emitter resistors, the rectifier, everything, all that sort of stuff. With a 4 ohm load on the output, this would be seen probably around about 6 ohms. So, 8 ohms is a little bit off of that just again. So, I mean, whatever temperature we measure it at, with both windings loaded at 8 ohms, if I double that temperature, that's going to be more than what it would probably be, at 6 ohms. So I think we can still work this out. I want to at least do it. I think it's, important to test it. So I'm still going to do it even though I can't produce 2 6 ohm loads at the same time at that sort of power dissipation. Actually, I'll have a look through my heating elements and stuff like that. I might actually be able to do it. I actually have rolls of nichrome wire and stuff like that as well. I might make up some resistive elements. I'll see. But I'll get this hooked up now. I probably will because I actually do want to accurately load this. I would love to load both sides at 6 ohms. Get that 8 amp draw. Although, you know what? Come to think about it, the voltage is going to sag more with both sides loaded. So it's not going to be 48 volts, which means it's going to be a lower voltage. So it probably would need 4 ohms on each side. You know what? I think this is going to work out good. I'm going to get this sorted out. I can still tell you one thing. Even if it does end up being a little bit too hot, like I said, for an amplifier, I think it's still going to be fine as long as you don't try and go above a 500 watt amp. But let's get this hooked up and see. Alright, so here's the setup. I've got the load bank here again. Currently configured for 2 8 ohm loads. I've got this set up now, center tapped, rectified, 2 caps. I'm looking across the total rail to rail on here, currently at 124 volts. Got the bridge rectifier on a heatsink. I've got the clamp meter here, and I've got this here so that I can put this in series and look at the current draw. So without further ado, let's get to it. Transformer's already on. I've had it running for about an hour again just to see. It's colder than it was yesterday. So yeah, it definitely runs fine on 240 with a small load or no load. So I'm going to get this hooked up now. I'm just going to unpower the transformer so I don't blow my banana plugs out. Although those capacitors are going to still have that much charge in them. Bugger it. Just be quick. Alright, I'm going to put the power back on I've got two 8-ohm loads, so an 8-ohm load across each winding. And that's already dropped down to 97 volts. I'm just going to take one of these off, put it in my amp meter, and stick that in there so that I can show you guys that we have about 6.2 amps. I'm just going to take all that back out and just directly put that in there, but 6.2 amps on each winding, continuous. Now, 250 watt amp's going to be drawing max of like, I don't know, 7, 8 amps, something like that. So this isn't far off of it, and this is a continuous draw, not like music playing. So this is actually quite a heavy load. This is probably still putting more of a load on the transformer than what it would see in a 500 watt amp. So I'm quite happy with this test. I guess all I can do now is wait, see how my temperatures are, and come back. Let's have a quick look at the primary. If I can. So, call it 3 amps. 3 amps going in at 240 volts. I'll boot the computer up so I can use the calculator and tell you guys exactly what everything's taking. Alright, I just turned everything off for a sec. Wanted to put a temperature probe in there because it's starting to get hot. As you can see, it was approaching 50 degrees Celsius. I've got a thermal probe going right into the top of the transformer there. It's squeezed in between that top plate and the rubber, so it's making very good contact. I'll just leave that there for now. I will say that I'm not comfortable with the heat I'm feeling, but again, I mean, it's getting hot to my hand, but it's still, you know, we'll see where this goes. I'll be back momentarily, let it run for a little longer, see what happens. There's no smell coming off the transformer. I can't hear, you know, the crinkling sound that you hear when windings are breaking down or melting slowly or anything like that, thermal expansion. So in that respect, we're good so far, but we'll see what happens. This temperature is increasing and at a fair rate. I want to see if it's going to stop somewhere or if it's going to get to the point that I need to turn it off. Be back soon. Oh, and I should just point out the total draw at the moment. 1 sec. Alright, so currently it's doing 576 watts. I think that's what my calculator told me. Yeah, 576. And it's approaching 60 degrees now, so I'm starting to get uncomfortable. Alright, if it's a class A winding, which is the lowest class, it can go up to about 90-95 degrees maximum. We're at 70 now, still increasing. It is not cold, it's not warm, it's an average day, so it's a good day to do this test. Like I said, bear in mind I am pulling a continuous 576 watts, I think it was, close to 600 out of it. Something a lot of people don't understand is in amplifiers, you really don't need... Look, I like to use, say, a 750 VA transformer for a 500 watt amp, but I have had no trouble running a 500 watt amp on a 500 VA transformer, and it's done just fine. The transformer only got warm. Music's not continuous, that's the thing. So the transformer doesn't see such a continuous load. Even with bass heavy music, you'd be quite surprised. It's still closer to a 50-50 duty cycle than full power. So, you know, this is the temperature has started to slow down. I do think it's going to stop before 95 degrees. It's a Chinese transformer, so I don't really want to trust it at 95, and I would never do that in practice anyway, like put it in a case and run it at that temperature, air cooled or not. But just for the sake of the test, I wanted to see, where it does max out at, if I can get it there before it reaches breakdown area. I'm doing the sniff tests and listen tests and watching the volt drop. It's dropped a few volts already. It's almost 3 volt drop since the heating has started, so the winding resistance has increased quite a bit. We're at 75 degrees Celsius now. Yeah, I can't really hold. I could hold my fingers on it because I've got pretty tough skin, but that's starting to get at the limit for me holding it. So I'm not going to go much above this. I probably won't go to 90, 95 even. I just feel that that's, a little bit too much. No, the copper's not even anywhere close to changing colour yet, but still, I just don't want to have a breakdown issue. I mean, I do have another one coming. It doesn't really matter if I destroy one. It's not like I'm going to burn my house down. I'm right here. It's not like I'm scared of these sorts of things, but I'm still trying not to destroy a good transformer. If I can have 3 instead of 2, that would be a good thing. I'll just wait another 5 minutes and then I'll come back. Alright, I'm going to end this part of the test here. It's only risen another 2 degrees in like that last 5 minutes, so it is slowing down. I think it's going to max out on a day like today in open air like that. I think it's going to max out at around 85 to 90 degrees, which is right at the limit. That's drawing a continuous 575 watts from it. So look, honestly, for an amplifier, this is definitely going to be fine for a 500 watt amp. It's not continuous at all. Transformer's going to run at least half the temperature it is now, and that's more than fine. So I will now happily give links to this. I'm happy to say that, you can run it on 240. You can run a 500 watt amp off of it. Don't load the amp any more than 4 ohms per channel. And definitely check the transformer temperature even if you do load it at that, just in case. Depending on the type of music you're playing, how continuous the RMS output is. But that temperature's gone up a lot. That voltage is decreased a lot as the winding resistance has gone up. It's at 85 degrees now. I'm going to turn this off. I'm going to just try one more test. I'm going to see if I can change my load very slightly. I just want to see something. Alright, I've changed the load very slightly. It's about the same. It's about 564 watts. I've just put 16 ohms across the entire winding, not center tapped. I'm just going to run it for another 5 minutes. So I've got a feeling it's going to be about the same. The other thing I was going to point out is, in an amplifier, say you've got 63 volt rails, the amplifier's max output voltage may be 44 volts or something like that, or 38 volts RMS. The rest of that voltage is getting dropped across the transistors, right? So depending on, the music that's playing and the effective dynamic resistance across those transistors, your transformer might not see as much of a load on it. Like I said, it just depends on the type of music you're playing, really, but from what I'm seeing here, I think it's going to be alright for a 500 watt amp. Just for reference, this is a 500 VA transformer that came out of a Precision Audio SM610 mixer with a 2x300 watt claimed output in it. I could never get more than 250 watts a channel out of it, both channels loaded. But I did get 500 watts RMS out into 4 ohms, and that was the transformer that was in it. And that transformer is just a tad smaller than this one, and it ran warm. So that's why I say I have a feeling this is going to work out. But I still wanted to do a more in-depth testing. We've got 3 degrees to go before I'm turning this off. I'm not going to go to 95. I think we can all see where this is going anyway. It's slowed down, but it still seems like it's going to make it before it actually reaches some sort of, what do you call it, equalization level. You know what I mean? It's going to be way too hot and reach breakdown before that happens. Something that could be done to improve the thermal performance of it is to remove this metal cap and pot the center of it, and then reinstall the cap, so that instead of there just being an air passage in the middle with a bolt going through, the actual core right in the middle where it's the hottest has got potting compound up against it with the bolt and the end cap against that, so that it could effectively dissipate the heat from the center of the core to the outside a lot better. That really helps with toroidal transformers. If you're wondering what I'm talking about, like this. This really helps to get the heat out. So I could look into doing that too to improve the thermal performance of this. But yeah, obviously once I've got the amps built, we'll load them up on, you know, a purely resistive load bank like this at 500 watts, run it off one of those transformers for say half an hour or whatever, and I'll document the temperature on it. So I'll tell you guys now, if you want to wait, you know, say another week for this to be finished enough for me to run that test before you go and buy them, I suggest doing that, because I just like to be thorough. Like I said, I don't want anyone to have problems. Hey, 93, 92, it's hovering. No way. Equilibrium. That's the word I was looking for. Don't tell me it's reaching equilibrium at the max temperature. Oh, this is hilarious. This is real funny. No strange sounds coming out of it yet. Doesn't smell. I can actually smell my load bank resistors. Smells a little hot. It doesn't smell like melty, it just smells warm. 94, okay. Wow, it looks like it's actually coming to rest around the 95 mark, with just over 500 watts RMS being continuously pulled. About 565 watts to be accurate. So yeah, I'm happy. This will work in a 500 watt amp, because it won't do that continuously. So it's guaranteed to be underneath that figure. And yes, the amp's going to have lower resistance loading on the output, but like I said, the transistors are not turned on all the way, so they take up a lot of that. Transformer won't actually see so much. That and the fact that music is not continuous. Oh, it has gone up to 96. Alright, I'm going to kill this test. Alright, well, I guess that kind of concludes it. It's continuous power, 500 VA. Hate to say it. That was just 64 watts to 75 watts over 500. And as you see, it was just starting to reach equilibrium at the max temperature. So, I mean, if you remove that extra 100 watts roughly, it'd probably be resting at about 80, 85 degrees, something like that, which is still too hot in my opinion, but yeah, fair enough. Okay. The advertised is an 1800 watts transformer. That's peak, so it should be 900 watts continuous. 500 watts continuous is a lot different to 900 watts, but again, they're $45. And seeing as it handles the, well, actually, you know what? That's one other test I might run, actually, before I end this video. I might put a bucking transformer in it and run it off 220. And we'll see at the same load if it still gets as hot, because I'm curious if that's actually the secondary winding being too thin that's making it get so hot, or the primary being run at too high of a voltage for the winding. So I think I'll do one more test. Sorry guys, I want to be thorough. I can't do this for long because this thing's only 500 VA, and I can tell you now it doesn't even do that because it gets really hot way under that. So I really can't do this for long. I'm going to melt that down, but I'm running off 220 and the temperature's already gone from 83 to 85. So it's not the 240 volt problem. I'm going to unplug this. Don't want to melt down my Variac. So yeah, it's not the 240 volt winding. The secondary winding's just a little bit too thin in diameter. That's the problem. So I ordered 40 volt winding, and unloaded we've got, one moment please. Unloaded we have 45 volts. That will go up. The transformer's quite hot at the moment. So 45 volts. Oh, it's unloaded, so maybe not. But anyway, 45 volts AC. So I guess rough rule of thumb, if you want 40, get like 36, or 35, 35, if that makes sense. Maybe even 34 to 36, something in that ballpark. Just be cautious of that to get the right output voltage, but at least the 220 volt winding is actually fine on 240. Only thing is, like I said, the max power you can get out of this thing without it going above breakdown temperature, and that's not in an enclosure on a hot day, was 500 VA. So if you wanted to use this thing for continuous power, I'd say 400 VA. If you want to put it in, say, a power supply, and you want to just draw a resistive load that's continuous RMS power, I wouldn't draw more than 400 watts continuous from it, because it'd be running at like 70 degrees, just like that, which is all right, but you wouldn't want to go over that continuous. For audio purposes, 500 1 amp, treat the transformer as a 750 VA transformer for a 500 1 amp. It'll be fine like that because it's not continuous. I hope that makes sense. But there again, like I said, you do have other things that come into play: the topology of your amplifier, the music you're playing, how much volt drop there is on the transistors, the impedance of the output of your amplifier. You're going to have to take things into consideration. So I will do a follow-up video when I put this transformer in an amp and load the amp 500 watts continuous, and we'll see what it does then into, say, 2 4-ohm channels. But until then, this is all the information I can give you guys on it. I'll include the link down below this video now. I just wanted to make sure that people know that, it's not as capable as what it's advertised of as, because I don't want anyone to burn their house down. All right. Thanks everybody for watching, and thank you Tanmera Tech once again for pointing out what you pointed out. It inspired me to do a follow-up video, and I feel a lot better about doing that, so thank you. You're a very valued contributor to the channel. Alright, take care everybody, and I'll see you all soon. Just a quick little update. I've decided to label them as 500 VA at 220 volt. Like I said, I think if you're running it at 240 and continuous, treat it as a 400 VA transformer. If you're using it for an amplifier, treat it as, like a 750 VA transformer that you'd put in at 500 1 amp. But like I said, still be cautious of loading. You might not be able to use it in a 500 1 amp if the output impedance is too low and the amp is like quite high efficiency between the input and the output, and the transformer sees a lot of that low resistance on its windings. It might not even do that. Like I said, I will test them properly in amps and give you accurate results, but for now I'd say 400 VA continuous, maybe use it in a 500 watt amp, treat it as a 750 VA 500 watt amp transformer. For non-continuous stuff, continuous, probably around 400 VA, and at least the 220 volt winding is seems to be alright for 240, so that's a plus.